this is an overview of section 10.2, arcs and chords. First definition, central angle, our angle whose vertex is the center of a circle, which is right here. This is my central angle. A minor arc is the measure of a central arc angle. APB is less than 180 degrees. Then A and B are the points of circle P in the interior of an angle APB. Basically, a minor arc is any arc measuring less than 180 degrees. And a major arc is any arc measuring more than 180 degrees. Naming arcs. Arcs are named by their endpoints. Minor arcs use only 2 letters. For example, AB with an arc over top would be an example of a minor arc. Major arcs, you will use 3 letters. So you could say ABC would be an example of a major arc. So I would start at A, I would end at C, and at some point I would go through point B. The measure of a minor arc is also the measure of its central angle. For example, if my central angle is 60 degrees, then my minor arc is 60 degrees. The measure of a major arc is technically defined as the difference between 360 degrees and the measure of its associated minor arc. All of these should have arcs drawn in over top of them. Find the measure of each arc of circle R. Well, MN is the same as the central angle, so that's going to be 80 degrees. I know that the other central angle, PRM, is 100 degrees. So then I know that MPN is that arc. That's going to measure 280 degrees. And PMN measures 180 degrees. Arc addition postulate. Basically, if you have 2 little arcs, you can add them together to get 1 big arc. It's the same thing that we did with angles and line segments. Find the measure of each arc. So GE has to be 40 plus 80. GEF would have to be 40 plus 80 plus 110. And G to F would obviously be whatever's remaining, so it would be 360 minus the 230, so it would be 130 degrees. Find the measures of the blue arcs. Are any of these arcs congruent? In part A, since they both have a central angle of 45 degrees, both arcs are 45 degrees, so they are congruent. In part C, arc XY and arc ZW equals 65 degrees, but XY and ZW are not arcs of the same circle or of a congruent circles, so they are not congruent. Okay? They can only be congruent if they're in the same circle or congruent circles. B, arc PQ and arc RS are in congruent circles, so they are congruent. And I know that these are in congruent circles because they have equal radii. Theorem 10.7 or 10.4 says that if the arcs are congruent, if and only if the line segments AB is congruent to BC. Okay, so arc AB would be congruent to arc BC only if AB is congruent to BC. Theorem 10.5 says line segment DE is congruent to line segment EF then I have that D arc DG has to be congruent to arc DF. And lastly, if one chord is a perpendicular bisector of another chord, then the first chord is the diameter. So because these are perpendicular bisectors, ML is a perpendicular bisector, that means JK has to be the diameter. So in example 4, we can use theorem 10.4 to find the measure of AD. Because AD is congruent to DC and arc AD is congruent to arc DC, we can set those two things equal to each other. So x equals 40. Theorem 10.7, in the same circle or in congruent circles, two chords are congruent if and only if they're equidistant from the same center. So a chord AB is congruent to chord CD because they're both the same distance away from my center. So in example 7, because AB and DE are congruent chords, they are equidistant from the center. So CF is congruent to CG. So to find CG, we first have to find DG. Okay. So because DE equals 8, DG must equal 4. Because CG is bisecting DE. Then I can use DG to find CG by doing Pythagorean theorem. So that means CG must be 3. And if CG is 3, that means CF also must be 3. This is a review of arcs and chords and theorems that are related to arcs and chords.